11? Okay, so here are our remote interior, right? So this one plus this one will equal that one.
Okay.
So -1 plus 8x plus 46 will equal 18x plus 5.
Doesn't have to be in a set of parallel lines to do the interior.
No, it's just the theorem is that the remote interior angles equal the exterior angle. So as long as we're on the opposite side of the triangle, this plus this will equal this.
So is it the opposite? I don't want to get confusing, so it's the opposite for saying if two exterior, like same exteriors will equal an interior.
So this one, this plus this will equal that. The theorem is if you have any triangle, right, with any exterior angle, A plus B will equal C. Here's why that works, okay, because the triangle is 180 degrees, right? So this plus this plus this is equal to 180. Well, this plus this is equal to 180. So that's why these two equal this one. Because both of them add up to this to equal 180. Does that make sense? Okay, so that's why that works. So back to, we have 8x plus 45 is equal to 18x plus 5. Subtract our 8x from both sides, and you get 45 is equal to 10x plus 5.
40.
We had that -1. Yeah. So subtract 5 from both sides. So 40 is equal to 10x. So x is going to be 4. Better?
What theorem is that?
This is the exterior angle theorem for triangles.
Are you making this
No, I didn't make it up. Somebody made it up like 2,000 plus years ago. So basically this is the same, except we're going to take it one step further, and we want to know the angle here. Well, that's 3x plus 4. So 3x plus 4 plus 8x plus 4 is going to equal 140. Okay, so 3x and 8x is 11x. 4 and 4 is 8. Subtract 8 from both sides and I get 11x is equal to 132. Divide by 11, x is equal to 12. But we didn't want to find 12, we want to find angle S, which is 3x plus 4. So 3 times 12 plus 4, 36 plus 4. So angle S is 40 degrees. All right, so we've got they're quads, so we added up to 360. So 11x minus 2 plus 86 plus 94 plus 94 equals 360. Okay, so 11x, that's 188
Yes.
plus 86. So, all right? Okay, hold on. That's an 8. 17, 274 minus 2, so 272. Okay, bless you. Minus 272 from both sides. So x is 8. Okay. So I've got two 90-degree angles. So 17x minus 3 plus 98, and I'm just going to say plus 180 because that's those two, equals 360. Okay, 180 and 98 is going to be 278 minus 3. Subtract 275 from both sides.
That's what you're out here.
85? Did I do that right? That's not right, is it? Oh, yeah. 85 divided by 17. 5. Bless you. Okay. This side will be equal to that side. This side is equal to this side. This angle is equal to this angle, and these two angles are equal in parallelograms. So if this is 135, this one's 135. And then these two will equal 180. So we do 180 minus 70, so that's 110. Any other questions on those first 6?
So number 3 is 100.
Uh-huh. Okay, how about 7, 8, or 9?
How about number 5?
Number 5?
Is it 23?
It's 23. Because the opposite sides are the same.
It looks scary. Got it.
I think that's because you're used to seeing parallelograms like sideways, and that one's up and down.
And it's got no mark. I thought it would be.
7 through 10? Number 7? Okay, so the diagonals bisect each other, right? So this length is equal to this length. This length is equal to this length, right? So if RT is 19.8, TP is also 19.8, so RP is going to be times 2. Okay, these two angles will add up to 180, right? We're just missing this little part of it. So we have to do 180 minus 60 minus 52.
How do you know that up to?
Because in a parallelogram, the two corners, any two corners, as you go across, adjacent angles will add up to 180. So
Adjacent. What about W and Y?
W and Y will be equal.
Oh.
Okay. So this entire angle plus that will add up to 180. Well, we have the 52, we just need the missing piece. So that's 120 minus 52, right? So that's 70 minus 2, so 68.
Will we ever have to find angle measurements based on length and sides?
Okay, so number 10, it's going to be the same thing. This angle plus this angle will equal 180. So 180 minus 62 minus 55. So that's 118 minus 55. So that's 63. So, yeah, number 13 would be the same.
Okay.
So that's 11x plus 70 equals 180. So 11x equals 110. So x is 10. Here these sides are equal. So we'd set those two equal to each other.
Wait. Especially the top one? equal.
They're parallel?
You don't have to show.
It's a rhombus, right?
It's probably just because they look exactly the same way.
Well, no, it's parallelogram, right? So we know if it is a parallelogram, these two sides are equal, and these two sides are equal. And then these two angles are equal, and these two angles.
The one's 2x plus 15 and the other's x plus 15 and the same way.
Mm-hmm.
See, that's why I was going to do, like, it would be a different equation, but x is always going to be the same on both sides.
Yes. 0.
Oh.
They're both going to be 15.
It's valid. Yeah. So both sides would be 15. X can be 0. X can be negative. So.
I see.
Remember, that's why I got confused on too. Like, it could be two different equations.
Yeah, they can be two different equations, but they have the same overall value. Okay. Math is fun. Okay. UH is 19. FH is 5x minus 7. UH is half of FH, right? So it's twice of that. So this would be 19, and this would also be 19, right? Does that make sense? So 5x minus 7 is going to be 38. So 5x is going to be 25. So x is, what, 9? Did I multiply that right?
Yeah.
Oh, I subtracted. Wrong.
Yeah.
I was supposed to add, not subtract. Plus 7. 45. Sorry about that. Just goes to show you on a Monday morning.
How'd you get 25 though?
Monday.
Because I was just off in la la land. Yeah.
UH is 19. Oh.
Okay, so a rhombus is just a parallelogram with 4 congruent sides. So if we were to draw that parallelogram, and we would say that all 4 sides are the same length. Okay. And then they follow all of the other properties of a parallelogram, where the opposite angles are congruent, the diagonals bisect each other. They follow every rule of a parallelogram because they are a parallelogram. They're just a 4-sided congruent parallelogram. Okay. So we have a couple theorems about them. If you have a parallelogram that is a rhombus, then the diagonals are perpendicular bisectors. So because the diagonals of a parallelogram bisect each other, and then they do so perpendicularly. So 90-degree angles. Okay, and it has to be a rhombus for this to be true, so you have to have 4 congruent sides. Okay. And then what will happen is these are congruent, and these are congruent. Okay. Now we also have, if the parallelogram is a rhombus, then the diagonal bisects the opposite angles. So if I have any diagonal and I come in like that, well, that's a terrible diagonal. Let me go from that corner, that corner to this corner. Okay, then this angle and this angle, these will be congruent because they're bisected. And it'll be the same going the other direction. So if we have the diagonals of a rhombus intersecting at K, all right, so I'm going to draw that really quickly. So rhombus. It's probably not exactly perfect. We're going to assume it is. Okay. I have diagonals bisecting. That didn't work. I can't get that lining up, but we'll just pretend that that's lining up correctly. Okay, so I have F, G, H, J, and they're intersecting at K. That's the picture. Okay, if the measure of F, J, H, so F, J, H is 82. So this whole angle is 82. We want to find the measure of K, H, L, K, H, J. Hold on, what did I mean to do? Wow, that's a massive typo. KJH. Yeah, so we'll do 82 divided by 2, 41 degrees. Good job, Angel. Okay, so half, right? Okay, if GH is x plus 9 and JH is 5x minus 2, we want to find x. What do we know about these two sides? If they're equal, because it's rhombus. Okay. So subtract x from both sides. 4x minus 2 equals 9. Add 2 to both sides. 4x equals 11. Divide by 4. And it doesn't, so that's okay. X will just be a fraction. We're fine with that. Yes, we are. And if we're not, we're going to pretend to be. Okay, a square is a special rhombus that has 4 90-degree angles. So we have parallelogram, right? Then there are 3 shapes underneath the characteristics of a parallelogram that are special. A rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 90-degree angles. And then a square is both. It has congruent sides and 4 90-degree angles. In the world of quadrilaterals, we have quadrilaterals within quadrilaterals that get progressively more special. Okay, so a quadrilateral is anything with 4 sides. Okay, inside there we have parallelograms, which have opposite sides congruent and opposite angles congruent. Inside of parallelograms, we have rectangles and rhombi. Rectangles have 4 right angles. Rhombi have 4 congruent sides. And when you combine a rectangle and a rhombus and they have a baby, it's a square. It has 4 congruent sides and 4 right angles. So the way this works out is every square is a rectangle, a rhombus, a parallelogram, and a quadrilateral. You can count it as any one of those things. But not every rectangle is a square, not every rhombus is a square, right? And not every parallelogram is a rectangle or a rhombus, and not every quadrilateral is a parallelogram. So if you were talking about being like the most generic to the most special, the square would be the most special because it is the most particular about the characteristics it has. Questions about that? If you have a parallelogram and the diagonals are perpendicular, then you have a rhombus. So if we have any old random parallelogram like that, and we come in here and we have diagonals and they turn out to be perpendicular, we get a rhombus. Okay. If we have any old parallelogram and diagonal bisects the angle and bisects this angle, we have a rhombus. Okay. If one pair of consecutive sides of a parallelogram are congruent. So remember a parallelogram says the opposite sides are congruent? So if we come in here and this one is the same as this one, that makes all four of them the same, right? So as long as you have consecutive sides being congruent, excuse me, you have a rhombus. And if you have...
So if only one pair are congruent, then it's a rhombus?
Well, if this one is congruent to this one's also congruent to that one, and that one's congruent to that one, and that makes them all four the same. So if I have a rhombus and I have a rectangle, nope, that's not a rectangle. There we go, read my mind.
Is that a chair?
I have no idea what happened to the plus sign.
That's a chair.
I'll fix it in a minute. No, it's not a square. Sometimes my shape recognition does not read my mind well enough. Alright, let's do this. Get rid of that. Okay, so we have a rhombus plus a rectangle equals a square. So first things first, we're going to graph this. So before I can graph it, I need axes. So X and Y. Okay. And J is going to be purple. There's J. K will make blue. Uh-oh. We're going to fix that. We're just going to move him over one. Okay. I do. I have the technology. I can do that. 1, 2, 3, 4, 5, 6, 7, down 2. Then we went to blue and we said 0, 4. And then I have 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. And then M will be red. 2, negative 4. 1, 2, 3, 4. Okay, now Is it a rectangle, a square, or a rhombus? That's what we've got to figure out. So first, let's just connect the dots and see what it looks like.
Can you do those lines in your color?
Yeah, what color do you want me to do them?
Well, I don't know black, but
Yeah, I can change them.
really?
Yeah, what color?
Blue.
All of the lines blue?
No.
Okay, what color for that line?
Make the
Rainbow blue.
Oh, what if I start with red? Okay, blue, what, indigo, violet.
You have to choose a bright color.
Okay, so far, what does it look like? It's obviously not going to be a rectangle or a square, right? Because we know that this is not 90-degree angles. Okay, so we can eliminate those two. Now we need to determine if it's a rhombus. In order to be a rhombus, all four sides have to be the same length, right? So we're going to count to get from this point to this point. How would I travel? I'd go up 1, 2, 3, 4, 5, 6, and then over 1, 2, 3, 4, 5, 6, 7. So I'd go up 6, over 7. Okay. To get from here to here, I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, and then down 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And then down 2 over 9. I know at least these two are the same length as each other, and that these two are the same length of each other. But I don't know if these two are the same length at this point. I think not, but I'm just going to double check at this point and do the distance formula. Okay, so I'm going to find the distance between J and K. And that's our distance formula. So -7 minus 0 squared plus -2 minus 4 squared. So that's 49 plus 36. 85. I'm just going to leave it there. And then I'm going to check the distance between K and L and see if they match. So I have 0 minus 9 squared plus 4 minus 2 squared. So that gives me the square root of 81 plus 4. They match. So now I know all four sides are going to be the same. Because I know these two sides are the same because I get the same triangle if I draw them. 4 minus 2 squared. Oh, -4. So, well, it would be, no, I did 0 minus 9 and 4 minus 2. I used K and L. So the distance is the same. So this is a rhombus. Okay. Trapezoids and kites. A trapezoid is a quadrilateral with one pair of parallel bases or sides. Okay. The bases are the sides that are parallel. And the legs are the sides that are not. Okay, the base angles are the angles made with one base and the pair of legs. And then you have two sets of base angles. One set for each base. Okay. And an isosceles trapezoid has congruent base angles and congruent legs. So I should record this. Okay. Trapezoid, bases, legs, okay, and then you have base angles. Okay, so this is one set of base angles, and this is the other set of base angles. And then an isosceles trapezoid, hopefully I can draw an actual isosceles trapezoid. Not. We'll pretend it's isosceles. Has congruent legs. These angles will be the same, and these angles will be the same. I didn't actually draw a very good isosceles trapezoid, but we're going to pretend.
That's what I ever seen.
Why, thank you. All right, as usual, we have some theorems. Well, it's if we have an isosceles trapezoid, it's not really quite isosceles. That's closer, but not quite, but still we'll say it's an isosceles trapezoid. Then each pair of base angles is congruent. So these are congruent, and these are congruent. Okay. If you have one pair of congruent base angles, so if we have some trapezoid and one pair is congruent, then you have isosceles. Okay. And you have in an isosceles trapezoid congruent diagonals. So I did not draw that one very well at all. Okay, so this is A, B, C, D. AC will be congruent to BD, provided the legs here are the same length. Questions on those? Okay. Have is that this is an isosceles triangle. It's actually a speaker. It's a very poorly drawn speaker, but pretend. That means these two legs are the same length. If FJH is 85 degrees and FK all right, hold on. FK is 8. We want to find, first of all, the measure of FGH. So if FJH is 85, we want to find FGH. Well, here's how we're going to do that. If this angle is 85, so we'll have big angle J is 85, right? And big angle H will then therefore be 85. And then big angle F and big angle G will equal each other. This is 170. Do you guys agree? So I have 170. If I take 360 and I subtract 170 from it, I get 190. Both of these angles together are going to equal 190 total. So if I divide 190 by 2, I get 95 degrees. So FGH is going to be 95 degrees. Good? Make sense? Because they're isosceles, so these two are congruent and those two are congruent. And it's a quadrilateral, so it's 360 degrees.
So it's just like what you.
KH. That's this part right here. Okay, the diagonals will be equal. Okay, JG is 19. Well, FH is FK plus KH. KH or HK, whatever. FK is 8. So that makes HK or KH 11. Make sense? First thing I want to do, I'm going to draw the picture. I'm going to make A blue. So -3, 4. I'm going to make B red. So 2, 5. I'm going to make C green. So 3, 3. And I'm going to make D black. So -1, 0. Okay. And to tell whether or not this is isosceles, what do I need? I need the legs to be the same size. Which two sides are parallel? Red, blue, red, green, green, black, or blue, black?
Blue, black. That's it.
Yeah, blue, black, and red, green, right? These two are the parallel sides. So I need to show that red, blue, and black, green are the same length?
Yeah.
Okay. So I need to find the distance between A and B and the distance between A and D. Sorry, not A and B. B and C. Red and green, so B and C, and blue and black. A and, no, wait, it's so very Monday, I apologize. I was right the first time. A, B, and then I need to find the distance of CD. A, B, C, D. So between A and B, -3 minus 2 squared plus 4 minus 5 squared. Okay, so -5 squared plus -1 squared. 25 plus 1, so that's the square root of 26. And CD, I have 3 minus -1, so 3 plus 1 squared and 3 minus 0 squared. So 4 squared plus 3 squared. 16 plus 9 is 25. Do those match?
I don't feel like they match.
They don't match. So it's not isosceles.